There are 20,000 miles of railway track in Britain that year on year support an ever-increasing number of train journeys. Every inch must be meticulously checked, and it takes a pretty special piece of kit to get the job done. This is the measurement train, the most technologically advanced train of its kind in the world. On board are a battery of sensors which are used to monitor the track as it rushes beneath it. Every 2 weeks, it surveys the entire mainline network and covers 110,000 miles a year. It's 4 a.m. at Old Oak Common Depot, and on-train technician Carl is preparing the measurement train for a long shift ahead.
As test trains go, this is the most expensive we've got on the network. It's the fastest we've got, and it probably produces the most data. Under here we've got a set of lasers and cameras. What I'm doing now is just cleaning them to make sure that they're ready for the day's recording. This train will measure pretty much every aspect of the track, from the overhead wires down to the track itself, and even below the ballast we'll be looking for any anomalies down there. All that's left really to do is climb back on board, get the computers fired up now, and then we'll go and get testing. There's an order to turning them on. It's a bit of a dark art.
Today, Carl and a team of technicians will be surveying the main line between Paddington and Plymouth.
We've got cameras, lasers, gyros. The train's basically looking for twist faults, cyclic, what's known as cyclic top, which is almost like a bumpiness in the track. Twist where the two tracks are literally not level where they should be, and an alignment fault where the track doesn't stay nice and true, or gauge where the actual distance between the two insides of the rails is too wide and the train would actually drop. Things that the public feel when they're actually on a passenger train.
As the data starts flooding in, the survey begins.
It's what's known as the track scan. It's a laser that's rotating underneath the actual carriage, laterally across the tracks. And these are the two rails that we are sat on. These are the ballast shoulders, and the ballast is the sort of foundations that the track is sat on. And this over here is the vegetation, and it's entering what's known as the cess. That's on the actual left-hand side over there.
While his team scan the track, Carl monitors the train's location.
Up here on the top screen we've got HD video. These images are used for track patrolling. Various people use them to identify bits of scrap rail, vegetation if it needs clearing out of the way of the tracks. There's quite a lot of functions for that. On this screen to my right we have basically the sat-nav of the railway. The red arrow is actually us to within around about 3 metres. It gives me full control to see where we've been. All of the instrumentation that was underneath the vehicle goes through the computers then process it. That comes out as a trace that you can see here. As a rule of thumb, the straighter these lines are, the better the track is. This is a development vehicle. These guys are currently working on the plane line pattern recognition. This is cutting-edge technology at the moment. Basically using the same sort of software as Facebook with facial recognition. It's just recognising items on the track that should or shouldn't be there and just alerting these guys to process it through.
If we found something on the train that give us an immediate block the line indication, we'd stop the train and literally phone it in and get somebody to go out immediately to deal with the problem.
With Carl and his team nearing the end of their shift, the data's looking promising.
We will have found some long-range defects, if you like, with larger timescales, very minor things that need tweaking. But as for immediate actions, I've had a very easy day. Although we may not have found anything, that is ultimately the goal. We don't want to find anything, so I'm more than happy with today's test.